Good afternoon, everyone. Am I audible to you?
Yes, ma'am.
Okay. So there are many students who have not joined Google Classroom yet. Please join it as early as possible because otherwise you will need permission to join everyday meetings. So please join Google Classroom. I will post every content for every day on Google Classroom only. Screen is visible to you?
Yes, ma'am.
Okay. So in the last class, we have studied about the logics, proofs. What do we mean by discrete structure? Some basic things, logical connectives, propositions, and all. So today I will start with the basic briefing. These were the six logical connectives that we have studied: the conjunction, disjunction, negation, exclusive, or conditional, and biconditional. The All the logical connectives we have studied with the help of truth tables only. So today we will learn about these logical connectives using truth tables as well as using different laws that we have to study within the discrete structure. So in conditional, P implies Q we have done. So P is actually the premise or the hypothesis, and Q is the conclusion or the consequence that we obtain from the hypothesis that is actually P. So in case of conditional, right. In case of conditional P and Q, P implies Q. We have studied how we can obtain the truth table, truth values. Like if P is false and Q is true, only in that case it will be false. Otherwise, rest all the cases will be true only, right? So this is a question based on the content that we have covered in the last class. So this is P join. Conjunction is actually join, and conjunction is actually made, and disjunction is actually join. So this is P disjunction negation of Q, जिसको हम बोलते हैं P join negation of Q, and this is conjunction negation of P join negation of Q. Then this is also join. So disjunction is referred as join, and conjunction is referred as meet. So this is a compound proposition. I have told you the compound proposition means any proposition which can be obtained from the combination of other propositions. So P and Q are two propositions. With the help of these two, I have added some logical connectives in conjunction, disjunction, negation, and I create a new proposition. This is the new proposition. Now my task is to show this proposition is tautology. Tautology means all the truth values should be true, and fallacy means all the truth values should be false. So in this case, P, because we have only two propositions, so number of rows in the truth table will be 2 to the power 2. So 4 rows will be there. So I have created this table. It is actually very simple. I hope you all know how to create a table. So P and Q, these are the propositional values, and then negation Q. Then I created P disjunction, P join negation Q, negation P join negation Q, because I need the meet of this one and this one. So I give the name 1, 2, 3, 4 so that it would be easier to understand how we are connecting these propositions. So I have created this table, and finally, when I create the 4 join 3, so the answer is coming out to be true. All truth values are true, so this means the final answer is a tautology. So these kind of questions are actually very simple, and you can attempt these questions. So I have written few questions here. This is your homework. Whatever homework is given to you, you have to submit day by day on the Google Classroom only. So I will create a Google Classroom. In the Google Classroom, I will create a folder assignment 01. So in assignment 01, the number of questions we covered, I will left as a homework in 1 week. So all the questions have to be attempted by you and have to be submitted as assignment number 1. So assignment number 1 के जो first question है, first 4 questions are these one only. So you will have to show the following are the tautology, right? So it's very simple because we have to just apply the truth table and then we will get the result. Okay, so I'm leaving it to you. Just create table and you will get it. Next notation is the well-formed formulas. Well-formed formulas is actually the expression or statement which we create with the help of propositions. Means we have studied the conjunction, disjunction, negation, conditional, and all other logical connectives. So any formula we obtain from given proposition is known as well-formed formula with the help of these connectives. So there are certain rules to obtain the well-formed formula. Number one is a propositional variable standing alone is a well-formed formula. Means if I am writing only P or any Q, so it is actually a well-formed formula. If I am not using any kind of logical connective, then it itself is a well-formed formula. If A is well-formed, then negation A is also well-formed. So if I am saying P is well-formed, then negation P is also well-formed. And there any logical connective like disjunction A, disjunction B, conjunction B, A implies B, A by conditional B, all are well-formed formula. So any expression you obtained with the help of logical connectives, then that will be a well-formed formula. Next is based on the conditional P implies Q. All of you knows like differentiability implies continuity. So if a function is differentiable, then obviously it is a continuous function. But if I say if a function is not continuous, then we don't need to check it the differentiability about that function. Means differentiability implies continuity, not continuity implies not differentiability. So P implies Q, not Q implies not P. That means not Q, negation Q implies negation P is actually true because differentiability है तो continuity होगी, अगर continuity नहीं है तो differentiability भी नहीं होगी, वो हम check भी नहीं करते. So negation Q implies negation P is actually known as the contrapositive of any conditional statement. So whenever we have a conditional statement, we have to read three things together: converse, contrapositive, and its inverse. So converse, we all know, we all used to do in the mathematical part. Whenever we prove something in the one direction, other direction is actually known as the converse. If P implies Q is conditional, then Q implies P will be the converse of that statement. Negation P implies Q is false. P implies P implies Q is true. You can recall the concept with the help of differentiability and continuity. That is very important concept in math. So वहां से आप इजीली इसको कॉल कर सकते हो. Then negation P implies negation Q is called the inverse of P implies Q. So whenever P implies Q is the conditional statement, these three statements are called converse, contrapositive, and inverse. Now you can have some questions regarding to this converse, contrapositive, and inverse. I will show it in the given tutor that I have already uploaded on the Google Classroom as well. So we will do some questions for these three. Next is the when two propositions are called logically equivalent. Two propositions logically equivalent means they have the same truth values. If one proposition is showing true for all the rows of the truth table, other proposition also showing the same values, then these two propositions are called logically equivalent. So compound proposition which have same truth values in all possible cases are called logically equivalent. Now we have certain types of question like show that the given propositions are logically equivalent. So we have two things to do in that case. One is we can solve the given two propositions. The values given for one proposition should be same as the value given for other proposition. Number two thing is we can obtain the P by conditional Q. If P is one proposition, Q is another proposition, you will have to solve about the P by conditional Q. If that result is coming out to be tautology, it is a true value for all the rows of the truth table, then the propositions are called logically equivalent. For example, like here it is the case: P implies Q, negation P join Q, negation P disjunction with Q. I have to show whether these are logically equivalent or not. So what we have done is these are the P and Q and negation P values. Then negation P join Q join R, the true false true true, and P implies Q are also the same thing. So if the truth values are same for these two proposition, so in all the possible cases, in all the four possible rows, then this means these two compound propositions are logically equivalent. One thing is this one. Other thing could what can be done is, in last fourth and fifth column, you just apply a by condition in this four and fifth column. If the by condition is coming out to be true, tautology in all the cases, then that is the possible thing that these two propositions are logically equivalent. So in case of column 4 and column 5, you can easily see that if I will apply by condition in these two columns, then definitely I will get tautology in all the cases. Why? Because by condition means by condition results in false only if either one of them is false. If both of them are true or false, you will get only true. So the final result will be tautology. So whatever you feel comfortable, you can do. Either you can do by condition, or you can just simply solve the different propositions. If you are getting the same results in all the cases, then that will be a logically equivalent propositions. Okay, this is the thing we have done with the help of truth tables. Other than truth tables, we have certain laws that we have already done in the set theory in class 11 and 12th. So the same laws work in discrete structures also. The first law is identity law. Identity itself means whatever I add in, let's say, any number. So say I have 3, what should I add in 3 so that I get 3 only? The answer is 0. What should I multiply 3 with so that I could obtain only 3? So answer is 1. So 3 plus 0 is 3, 3 dot 0 is 3, 3 dot 1 is 3. So that is the identity. Identity means anything which is not changing the identity of the given proposition. So what should I do conjunction and disjunction with proposition P so that I obtain the proposition P only? So if I will take conjunction with tautology, then I will get P. And if I will take disjunction with fallacy, then I will take P. Fallacy means all rows false, tautology means all rows true. So this is identity law. Domination, as the name suggests, we are dominating something like. So what is the proposition which will dominate the proposition P? So T, tautology, is the proposition which is dominating P over T. So if I will take disjunction of P with T, then I am getting tautology. And if I'm taking fallacy conjunction with P, then I'm getting fallacy. So this shows who is dominating P. The third one is idempotent law. Idempotent means, as we do in algebra also, p square equal to p, like it's that kind of thing. If I'm multiplying p with p, I'm getting p. If I'm adding p in p, I'm getting p. So p conjunction p is p, and p disjunction p is p. So that is idempotent law. Next one is double negation. Double negation, obviously, negation of negation is P, that is double negation. Commutative law, if you will add A plus B or B plus A dot B and B dot A, result will same. So same case with conjunction and disjunction. The sixth one is associative law. Associative law, if you have three proposition, so with the same operation, disjunction is same. P join Q join R. If I am operating firstly P and Q, then I am operating R, or I am operating Q and R, then I'm operating with P, the resultant will remain same. So that is associativity. The only point to note here is I'm using the same operation within the one proposition. So either conjunction or disjunction. If I will use
Excuse me, ma'am.
G, yes,
Ma'am, for the conditional statements, commutative law would not be valid, right?
conditional statement commutative law will not be valid. True. So the laws I'm talking about, these are valid only for conjunction, disjunction, and negation.
Okay, ma'am.
Seventh one is distributive law. Distributive means one operation is distributing over the other operation. So we have two operation, conjunction and disjunction. So this disjunction is distributing over conjunction, and in the same way conjunction is distributing over disjunction. So in the same way we used to study with the plus and dot. Plus is distributing over dot, and dot is distributing over plus. So if I want to apply disjunction over conjunction. So what we can do is either left hand side says firstly operate q and r, then operate with p, and right hand side says firstly p and q, operate p and q, then operate p and r, and then operate both. This is a distributive law. So disjunction and conjunction are distributive over each other. The eighth one is De Morgan's law. De Morgan's, as in the set theory, complement. It talks about the complement. Complement of the union is actually the intersection of the complements. In the same way, the negation of disjunction, P disjunction Q is negation of P and negation of Q. Meet, negation of Q. So disjunction's negation is meet, conjunction's negation is join. So this is De Morgan's law, and this is actually true in all the cases, because if you will take disjunction with negation of P negation P, then it will be true. Conjunction of P negation P is false, always false. Like in next question, the question is, without using truth tables, show that the following two statements are logically equivalent. One way is you can use truth table, other way is you can use these law. If it is written clearly in the question that you cannot use truth table, if it is there in exam and you are still using truth table, you will not get any marks. I know you will get definitely same result, but if it is written that without using truth table you cannot use truth table, you will have to use the laws only. So, and the number one condition is this one. Second condition, if you are using any law like idempotent law, De Morgan's law, or associativity, you will have to name it at the place where you are using. If you are not naming it and you are using without naming it, the marks will be deducted in the exam. So I have to show these two statements are logically equivalent. The method is you can take one and show where it is illogically equivalent to another one. So I have taken the first one, negation of this one. So it's actually, firstly I will apply De Morgan's law here. Negation of P, join's negation will be meet, then negation of this complete statement. This like this. Again, I will using De Morgan's law in the second statement. It will be P join negation of Q. Now the third thing, here we have here we have meet in the starting and join in the second operation. So we have two operation, meet and join. So the law I will use here is distributive law. If they are same, join and join, then I can use either associativity or distributivity. But if they are different, one is meet and one is join, the only law I can use is distributive law. So that is why I'm using negation P and negation P, join negation P and negation Q. So that is the distributive law. Again, negation P and P is false, so fallacy, so that is F. Join with the same thing. If you will take join of any proposition with fallacy, you will get the same proposition. That is why I'm getting this much proposition only. So here we have used three law. De Morgan law in the very first attempt, again use De Morgan law, then we have used the distributive law. So you have to name De Morgan's law in the very first row and distributive law in the third row. So this is the procedure to attempt this question without using truth tables. Similarly, this is with the help of truth table only. We have another question. We have to show P implies Q and P implies R. This is logically equivalent to P implies Q and R. So we have to show these two compound propositions are logically equivalent. Without using truth table, I'm doing this question. So I start with this P implies Q and P implies R. Now, P implies Q. If you remember this thing, I have shown P implies Q is logically equivalent to negation P join Q. This is very important. Whenever you get any question about conditional statement, this you will have to use it. Without that, you will not be able to apply any law. Why? Because on conditional statement we don't have any law. All the 8 laws are talking about the disjunction and conjunction. So firstly we will have to convert this conditional statement into disjunction only. So P implies Q is logically equivalent to negation P join Q. So whenever P implies Q, I will substitute negation P join. P implies R is logically equivalent to negation P join R. So there we are using the above result. And here in the second row, a negation P join Q and negation P join R. So again I am using the distributive law. Why? Because negation P is common in both the brackets. Negation P is taking common out and then join with the Q and R. Q meet R. So this is distributive law. Again, negation P join something. It is logically equivalent to P implies something. P implies Q is logically equivalent to negation P join Q. So that is why I'm writing P implies Q and R. So these two statements are logically equivalent. This is another question. P biconditional Q.
Excuse me, ma'am.
Yes, tell me.
Ma'am, in this one where we use the properties of P conditional Q, do we have to mention the property by using the truth table? That how do we
You
call it?
will have to, yes, you will have to mention it. If
Okay, ma'am.
uh if you have time, you can prove it using truth table also. If you don't have time, you just write it.
Okay, ma'am.
The next question is P biconditional Q is logically equivalent to this statement. So I start with P biconditional Q. I told you P biconditional P if and only if Q means P implies Q and Q implies P. That is why I'm writing P implies Q and Q implies P. Then P implies Q means negation P join Q. Q implies P means negation Q join P. So these are the two statements I'm getting. Again, here we have three operations: join, meet, and join. So what I am using is distributive law here. So first negation P and the second bracket is same, negation Q join P. Then join Q and the second bracket. So first this is the disjunction, this is the meet, conjunction. So disjunction is distributive over the conjunction. So I am treating this negation P is one, Q is second, and this whole bracket is the third one. That is why I am applying the distributive law here. Again apply distributive law on these single brackets. So negation P and negation Q, negation P and P. In the between of these two you will get join. Then Q and negation Q, join Q and P. Negation Q, P and negation Q will remain same. Negation P and P will be fallacy. Q and negation Q will be fallacy. Q and P will remain same. And any proposition disjunction with fallacy will remain the same proposition. That is why I'm getting this proposition. So I have shown P biconditional Q is logically equivalent to negation P join Q, negation Q join P, negation P join Q. So these are logically equivalent. Any doubt till now?
Excuse me, ma'am.
Mm-hmm.
What if we take, like, instead of joining negation P and negation Q, that thing, what if we do negation P and then with the Q part, the or part with the Q ones
In the row,
in the
in
third
the
row?
in third row, like
When
this
we are
one.
using the distributive law,
Hmm.
what if we take negation P as the first one,
Hmm.
Q as the second one, and that whole thing, no, Q as the third one, and then whole thing the second one. Negation P union Q, union P.
Huh, I have applied from the left to right. You can apply on the right to left as well.
Okay,
In that case, you will treat first bracket as single one, and then second, and then third one. So this negation P join Q will be your first bracket, and negation Q will be your second term, and P will be your third term.
okay,
You will get same result.
okay.
Any other thing?
No, ma'am.
Okay. So the tune sheet I have shared with you. Firstly, I will do some questions. So this is question number one. From these questions, I want to show what kind of questions you can expect in exam in case of discrete structures. So whatever we have covered till now is what do we mean by proposition, what is propositional variables, what is logical connectives, what how to use truth tables, and how to use the laws, right? Using these things we will do some questions. First question is, we have three propositions P, Q, and R. P is grizzly bears have been seen in the area. Q is hiking is safe on the trail. And R is berries are ripe along the trail. Then write these proposition using P, Q, and R and logical connectives, including negation. So what is question saying? Question is asking you about the framing a new proposition with the help of the given proposition using logical connectives. So we have to obtain a well-formed formula with obtained from the given formulas. We have some proposition, we have to obtain a new proposition with the help of connectives. So the first question is, berries are ripe along the trail, but grizzly bears have not been seen in the area. So tell me, what will be the proposition you will obtain using the given proposition? Berries are ripe along the trail. This is proposition R. Grizzly bears have been seen in the area. This is proposition P. Here it is grizzly bears have not been seen in the area. This is proposition Q. Here the term is but. Whenever you get and or whenever you get but, you will use conjunction only. So berries are ripe along the trail will be R. Here it is but, so you can use conjunction. Grizzly bears have not been seen in the area, negation P. So R and negation P. So answer is R and negation P. This is the solution. Second, grizzly bears have not been seen in the area. So that is negation P, and hiking on the trail is safe, that is Q. So negation P and Q, conjunction Q. But berries are ripe along the trail. But के लिए भी हम conjunction use कर रहे हैं, conjunction R. So answer is negation P, conjunction Q, conjunction R. So this is the final answer. Third one, if berries are ripe along the trail, whenever we have if, that means condition. So P implies Q. If berries are ripe along the trail, hiking is safe if and only if grizzly bears have not been seen in the area. What will be the answer in this case?
R condition Q by condition negation P.
R condition, any bracket?
Yeah, R condition Q is in brackets.
R condition Q is in bracket. Are
And
you
then
sure?
by condition with negation P.
P, negation P, huh? All of you are getting same. If berries are ripe along the trail, hiking is safe if and only if this thing. So the statement you are talking about is different in brackets, in terms of bracket. Here are, if berries are ripe along the trail, are condition then, उसके बाद then के बाद जो कोमा है वो सारा एक ब्रैकेट में है. हाइकिंग इज सेफ, हाइकिंग इज सेफ मतलब क्यू, इफ एंड ओनली क्यू बाय कंडीशन नेगेशन पी. तो क्यू बाय कंडीशन नेगेशन पी इज इन वन ब्रैकेट, एंड बेरीज आर राइप अलोंग द ट्रेल इज आर. आर के साथ वो जो सेकेंड ब्रैकेट आई उसके बीच में कंडीशन आएगी. सो आर कंडीशन क्यू इफ एंड ओनली इफ नेगेशन पी. जो कोमा लिखा हुआ है ना, स्पेशली कोमा है, इसका मतलब इफ बेरीज आर राइप अलोंग द ट्रेल. सो दिस इज वन सेंटेंस. उसके बाद जो आ रहा है वो सारा का सारा कंडीशन में आएगा. सो पी आर के साथ जो उसके बाद है वो सारा कंडीशन में. अब उसके अंदर क्या है वो फर्दर फिर ब्रैकेट में आएगा. इज इट क्लियर?
Okay, so the statement after the comma is like
सेपरेट वन.
R is conditioning to the whole statement, which is
हाँ,
after the
ट्रू
comma.
ट्रू. आर इज कंडीशनिंग टू द होल स्टेटमेंट. ट्रू.
Okay.
It is not safe to hike on the trail. It is not safe to hike on the trail, matlab negation of q. But conjunction, grizzly bears have not been seen in the area, means negation p, and the berries are along the trail are ripe, that is r. So this is very simple, negation q and negation p and r. The fifth part is hiking is not safe on the trail whenever grizzly bears have been seen in the area and berries are ripe along the trail. Attempt E part. What will be the compound proposition in this case?
Q whenever P. Q whenever hiking is not safe, though negation Q. Being seen. P implies negation Q and there. Ma'am, P implies negation Q, conjunction R.
Hmm.
Mm,
P implies, P means hiking, he is not safe on the trail. That is Q. Q whenever P.
P. So that's P implies Q.
Hmm. And
P
berries
implies
are what?
negation Q.
Berries are ripe along the trail is R.
R.
So whenever के बाद वाली statement क्या है? Whenever के बाद वाली.
P
Grizzly bears have
conjunction
been
R.
seen in the area means P, and berries are ripe along the trail R. So P and R जो है whenever के बाद आएंगे. So whenever के बाद जो आ रहा है वो P होता है, implies whenever के जो पहले होता है वो Q होता है. P implies Q. Q whenever P. So मेरे केस में ये P क्या बन गया?
P.
P
So the
and
whole statement after whenever is P
हाँ, P
and
and
R.
R is P and R. Condition hiking is not safe on the trail, that is negation Q. So P and R implies negation Q. So this is answer. Okay, next one. P and Q are two proposition. You drive over 65 miles per hour, you get a speeding ticket. Write the following proposition using P and Q and logical connectives. So the first one is you do not drive over 65 miles per hour. P है you drive, and you do not drive, definitely negation P हो जाएगा. The first one is very simple. Second है you drive over 65 miles per hour but you do not get a speeding ticket. But है तो and आ जाएगा conjunction. So P and you do not get a negation Q. तो answer is P and negation Q. The third one is you will get a speeding ticket if you drive over 65 miles per hour. So Q if P. If P then Q, or Q if P, दोनों same है. If you drive over 65 miles per hour, that is P, you will get a speeding ticket, that is Q. But जो लिखने का स्टाइल है वो Q पहले लिखा गया है, if के बाद P आ रहा है, तो आंसर will be P implies Q only. यहाँ इस केस में Q is speeding ticket है, P is 65 miles driving है. So Q if P है तो इसमें it means P implies Q. तो आंसर will be P implies Q. If you do not drive over 65 miles per hour, then you will not get a speeding ticket. You do not drive means negation P. You do not get a speeding ticket means negation Q. So negation P implies negation Q. It's very simple. Again, driving over 65 miles per hour is sufficient for getting a speeding ticket. क्या आंसर आएगा इसका? E part का. Something is sufficient for something.
P implies Q.
हाँ, 65 miles driving is P, getting a speeding ticket is Q. So P is sufficient for Q, that means P implies Q. So these are different ways to write a conditional statement that we have covered in our last class. You get a speeding ticket, but you do not drive over 65 miles per hour. But है तो definitely and वाला काम करेगा, conjunction आ जाएगा. Next, the last part is whenever you get a speeding ticket, you are driving over 65 miles per hour. सो वेनेवर आएगा तो डेफिनेटली कंडीशन वाली बात हो रही है फिर से. तो कैसे लिखते थे वेनेवर को? वेनेवर यू गेट अ स्पीडिंग टिकट, पी इंप्लाइज क्यू के लिए क्या होता है? क्यू वेनेवर पी. तो वेनेवर के बाद जो है वो डेफिनेटली पी है, और जो उसके पहले या उसके बाद में कोमा के बाद लिखा गया है दैट इज क्यू. यू आर ड्राइविंग ओवर 65 miles per hour implies you will get a speeding ticket. So this means Q implies P. So the last part is Q implies P. Is it clear?
मैम ये असाइनमेंट में कैसे लिखना है, मतलब ये
असाइनमेंट में कैसे लिखना है मतलब?
जो आंसर्स लिखने होंगे, सबमिट करने होंगे, तो
ये नहीं करना बेटा आपको असाइनमेंट के लिए। असाइनमेंट में जो मैंने नोट्स में क्वेश्चन छोड़े हैं, अभी मैंने
ओके
नोट्स में कुछ होमवर्क क्वेश्चन छोड़े हुए हैं ना,
ओके मैम।
अभी कुछ ट्यूट शीट्स तो एक दो ट्यूट शीट्स तो मैं आपको करवाऊंगी। ट्यूट शीट्स आपको क्लास के यूनिट वाइज मिलती रहेंगी। तो ये मैंने कल ट्यूट शीट जो अपलोड करी है उसमें 20 क्वेश्चंस हैं। आज की क्लास में जो मैं क्वेश्चन कवर कर रही हूँ, आई गेस 8 या 9 क्वेश्चंस कवर कर रही हूँ। देन 8 या 9 क्वेश्चंस आज मैं आपको सारे ये करा रही हूँ, विद सोल्यूशंस आपको ये प्रोवाइड कर रही हूँ। आई विल अपलोड ऑन द क्लासरूम एज वेल। तो अभी तो आप प्रैक्टिस करेंगे, धीरे धीरे ऑब्वियसली मैं ट्यूट शीट्स आपकी लीव कर दूंगी, फिर आप लोग सबमिट करोगे, देन ओनली वी विल डिस्कस इन द क्लास, राइट? Okay. Question number 3. For each of these sentences, determine whether an inclusive or an exclusive or is intended. Explain your answer. ये आप बताएंगे. Coffee और tea comes with dinner. Inclusive और exclusive और कौन सा होएगा ये? Inclusive और था जो कि हम नॉर्मल डिसजंक्शन करते हैं, P डिसजंक्शन Q, जिसमें ईदर P और Q और बोथ आर ट्रू। एक्सक्लूसिव और का मतलब होता है ईदर P इज ट्रू और Q इज ट्रू, नॉट बोथ। तो कॉफी और टी कम्स विद अ डिनर, हमें क्या लेना चाहिए इसे, इंक्लूसिव और या एक्सक्लूसिव और?
एक्सक्लूसिव और
एक्सक्लूसिव। हम ये मान के चलते हैं, जो मैंने क्लास में भी एग्जांपल दी थी, कि आप कॉफी या टी ऑर्डर करते हो, दोनों नहीं कर सकते, तो दैट इज वाई एक्सक्लूसिव। अ पासवर्ड मस्ट हैव एटलीस्ट 3 डिजिट्स और बी एटलीस्ट 8 कैरेक्टर्स लॉन्ग। अगर आप कोई पासवर्ड सेट कर रहे हो किसी सिस्टम का, इट शोज कि इट मस्ट हैव एटलीस्ट 3 डिजिट्स और एटलीस्ट 8 कैरेक्टर्स लॉन्ग। और बोथ भी तो हो सकता है ना, आप 3 डिजिट्स भी डाल दो और 8 कैरेक्टर लॉन्ग भी कर दो, तो ठीक बात है, इंक्लूसिव हो आ जाएगा इस केस में। फिर the prerequisite for the course is a course in number theory or a course in cryptography. I am saying to study discrete structure, you need to do either number theory or cryptography, but I cannot refuse the student who has done both. So if you have done both the courses, even then you are allowed in discrete structure. So this is also inclusive or. You can pay using US dollar or euros. ये क्वेश्चन काफी सब्जेक्टिव है, इंटरप्रिटेशन पे इंटरप्रिटेशन के लिए है, इसीलिए मैंने यहाँ पे लिख दिया है क्लियरली। इंटरप्रिटेशन कुछ भी हो सकती है। अब ये हो सकता है कि जैसे सपोज आप किसी कंट्री में गए हो, आपके पास लेट्स से आप अगर कहीं ट्रैवल करते हो तो एयरपोर्ट्स पे जनरली यूएस डॉलर में पेमेंट ली जाती है, ठीक है? सो देयर इज स्ट्रिक्ट रिस्ट्रिक्शन दैट यू कैन पे ओनली इन यूएस डॉलर ओनली or in euros, not both. So in that case, it will be exclusive or. If the person says, okay, you can pay half amount in US dollar, half amount in euros, so both are allowed. So in that case, it is inclusive or. So this question is quite subjective. So mixture of the two principles is possible as per the choice. So subjective one, inclusive, exclusive, दोनों possible है इस case में. Okay. The question number 4. State the converse, contrapositive and inverse of each of these conditional statements. जो हमने आज करा है, converse P implies Q का जो converse होता है Q implies P होता है. Contrapositive is negation, Q implies negation P होता है. Inverse होता है negation P implies negation Q. अब conditional statement क्या है? If it snows today, then definitely then है तो कोमा है. I will ski tomorrow. If tomorrow. Now you have to write the converse, contrapositive and inverse. तीनों लिखने हैं इस स्टेटमेंट के लिए। अब कन्वर्स क्या होता है? P implies Q का Q implies P, तो क्या होगा? If I ski tomorrow, then it snows today. ऐसे ही होना चाहिए ना, कि if I will ski tomorrow only if it snows today. अब ये राइटिंग का वे है। P implies Q को मैं P only if Q भी लिख सकती हूँ। तो मुझे लिखना क्या था? I will ski tomorrow. If I will ski tomorrow, then it snows today. But it sounds little bit confusing. So that's why I have written I will ski tomorrow only if, in the sense of only if it snows today. Contrapositive will be P implies Q. Contrapositive is negation Q. Negation Q is if I will not ski tomorrow, then it doesn't have snow today. So this is a contrapositive. Inverse क्या होता है? इट स्नोज टुडे का नेगेशन, इफ इट डज नॉट स्नोज टुडे देन नेगेशन क्यू, आई विल नॉट स्की टुमारो. सो दिस इज द इनवर्स. ठीक है, ये मैंने क्वेश्चन बी और सी पार्ट इसका लीव कर दिया है, ये आपके होमवर्क के लिए है. ठीक है, आप ट्राई करो इसका कन्वर्स. आई कम टू क्लास वेन एवर देर इज गोइंग टू बी अ क्विज. इसका कन्वर्स, कॉन्ट्रा पॉजिटिव एंड इनवर्स. देन अ पॉजिटिव इंटीजर इज प्राइम only if is same as if p then q. If a positive integer is prime, then it has no divisors other than 1 and itself. इसको मैं ऐसे लिखूं या फिर ओनली इफ करके लिखूं, एक ही बात है. p implies q is same as p only if q, राइट. सो इसको जब भी आपको कन्वर्स, कॉन्ट्रा पॉजिटिव एंड इनवर्स राइट करना है, सबसे पहले आप इसको इफ देन की स्टेटमेंट में कन्वर्ट करिए. जैसे यहाँ सेकंड में मैंने वेन एवर डाला है एंड थर्ड में ओनली इफ डाला है. दिस इज जस्ट टू मेक श्योर कि आपको ये स्टेटमेंट्स के मतलब पता है. तो आप इसको फर्स्टली इफ देन में लिखेंगे, देन कन्वर्स एंड कॉन्ट्रा पॉजिटिव में मिस्टेक्स कम होंगी फिर आपकी. अगर आप सीधा वेन एवर ओनली इफ से ट्राई करोगे तो थोड़ा चांसेस है कि आप गलत करो उसको. ठीक है, ये वाला क्वेश्चन नंबर 4 जो है ये कंप्लीट करके आप नॉर्मली सिर्फ कर लेना. अगर किसी को कोई प्रॉब्लम आ रही है तो कल वाली क्लास में डिस्कस करेंगे. ये क्वेश्चन मैं कल क्लास में देखूंगी एक बार. ठीक है, ये आप दिखाओगे कि कैसे लिखा आप लोगों ने. क्वेश्चन नंबर 5, ये आपका जस्ट वही है जो कंपाउंड प्रोपोजिशन के आपको ट्रुथ टेबल बनाने हैं. इनके जस्ट ट्रुथ टेबल बनाइए, जो भी वैल्यूज आ रही हैं यू विल गेट द आंसर. दिस इज जस्ट फॉर द सेक ऑफ योर प्रैक्टिस. क्वेश्चन नंबर 6 इवन, ये जो है ये क्वेश्चन नंबर 6 ही है इवन, ये स्पेस के बाद मेरे से मिस्टेक हुआ है कुछ. ये ट्यूट शीट में करेक्टेड है जो आपके वहां पे अपलोडेड करी गई है. ये 5 एंड 6 है, ये 6 का ये पार्ट है. दोनों 5 एंड 6 आर फ्रॉम द सेम कंपाउंड प्रोपोजिशन के ट्रुथ टेबल ही बनाने हैं आपको. क्वेश्चन नंबर 7 एंड 8 में भी आपको ट्रुथ टेबल के थ्रू शो करना है कि दीज आर लॉजिकली इक्विवेलेंट. 5 6 7 8. ठीक है, ये आपका होमवर्क है. ये आपको क्वेश्चन नंबर 5, क्वेश्चन नंबर 6, क्वेश्चन नंबर 7 एंड 8 ये आप ट्राई कर लेना विद द हेल्प ऑफ ट्रुथ टेबल, राइट. क्वेश्चन नंबर 9, यूज डी मॉर्गन्स लॉ टू फाइंड द नेगेशन ऑफ ईच ऑफ द फॉलोइंग स्टेटमेंट. अब डी मॉर्गन हमें पता है कॉम्प्लीमेंट के बारे में बात करता है. नेगेशन ऑफ डिसजंक्शन इज कंजंक्शन, नेगेशन ऑफ कंजंक्शन इज डिसजंक्शन. Kwame will take a job in industry or go to graduate school. तो अगर मैं P ले लूं कि he or she will take a job in industry, Q is go to graduate school. तो P join Q है. इसके ऊपर डिमॉर्गन लॉ लगाऊंगी तो नेगेशन P एंड नेगेशन Q हो जाएगा. तो उसको मैं कैसे लिखूंगी? Kwame will not take a job in industry and not go to graduate school. Yoshiko knows Java and calculus. एंड है तो उसका नेगेशन और हो जाएगा. योशिको डजंट नो जावा और डजंट नो कैलकुलस. जेम्स इज यंग एंड स्ट्रॉन्ग, एंड है तो और हो जाएगा. जेम्स इज नॉट यंग और नॉट स्ट्रॉन्ग. रीटा विल मूव टू दीज टू कंट्रीज, ओरिगन और वाशिंगटन. सो और का नेगेशन विल बी एंड. So these are just words where you have to write the compound proposition using the De Morgan's law. Clear? सो दिस क्वेश्चन नंबर 4 5 6 7 8 ये ट्यूट शीट के वो क्वेश्चन है जो आपको करने होंगे. एनी डाउट टिल नाउ?
नो मैम.
ओके,
मैम वो व्हेनेवर वाला फिर से बता दो एक बार.
क्वेश्चन नंबर
अ,
क्वेश्चन नंबर 4 का सेकंड.
या नहीं 4 का सेकंड नहीं, इससे पहले भी एक व्हेनेवर का बताया था आपने, सेकंड में आएगा.
जी पार्ट.
हाँ ये जी पार्ट. यस.
एक्चुअली जब भी आप व्हेनेवर कहते हो, व्हेनेवर P implies Q is same as if P then Q. इसका मतलब क्या हुआ? Q कब हो रहा है? जब P हो रहा है. तो इसको मैं कैसे लिखूंगी? Q whenever P. आर यू गेटिंग? या Q when P. तो बेसिकली जब भी आपको इफ देन की बात करनी है आप इसको अलग अलग तरह से लिख सकते हो. तो वेन एवर इज वन वे, क्यू वेन एवर पी लिखने मतलब हम लिख सकते हैं. तो जब भी आपके पास है वेन एवर यू गेट अ स्पीडिंग टिकट, यू आर ड्राइविंग ओवर 65 miles per hour. सो इसका मतलब क्या हुआ Q whenever P, whenever you get a speeding ticket, मतलब whenever P, तो Q इसमें क्या हो गया, you are driving over 65 miles per hour. Q whenever P, तो इसका मतलब हुआ you, if you get a speeding ticket, then you are driving over 65 miles per hour. तो इसका मतलब सेम हुआ if P मतलब P इस केस में क्या हो गया, if you are getting a speeding ticket, then you are driving over a 65 miles per hour. तो इसका मतलब get a speeding ticket was Q, if Q then P, तो answer will be Q implies P. If you are getting a speeding ticket, if you get a speeding ticket, then you are driving over 65 miles per hour. तो whenever के बाद जो है that is P, whenever के पहले या कोमा के बाद जो लिखा हुआ whenever के साथ वाला P है, उसके अलग जो पार्ट है that is your Q in case of P implies Q. तो Q whenever P. क्लियर?
यस मैम क्लियर।
इसमें क्वेश्चन के फोर्थ के बी में भी है आई टू क्लास whenever there is going to be a quiz. अगर मैं कह रही हूँ there is going to be a quiz P है, I come to class Q है, whenever there is going to be a quiz, तो इसका मतलब P implies Q. तो इसको मैं कैसे लिखूंगी, if there is going to be a quiz I come to class, then I come to class. तो इसको स्टेटमेंट बन गई if there is going to be a quiz then I come to class. ठीक है, अब इसके हिसाब से आपको कन्वर्स, कॉन्ट्रापॉजिटिव एंड इनवर्स राइट करना है इसका। ओके, सो इसका ना मैं ये शीट के 9 क्वेश्चन है, इसको मैंने स्प्लिट कर दिया था इसके आंसर्स राइट करने के लिए। जस्ट आपको मैं ये आंसर्स के साथ आज फॉरवर्ड कर देती हूँ 9 क्वेश्चंस के, आप एक बार देख लो, कहीं पे भी कोई डाउट है देन जस्ट आस्क टू मी, वी विल डिस्कस इन नेक्स्ट क्लास, राइट। सो नेक्स्ट क्लास में हम स्टार्ट करेंगे रूल्स ऑफ इन्फ्रेंस। रूल्स ऑफ इन्फ्रेंस भी एक मेथड है, ट्रुथ टेबल इज वन मेथड, लॉज इज सेकेंड मेथड, रूल्स ऑफ इन्फ्रेंस इज द थर्ड एंड मोस्ट इंपॉर्टेंट मेथड टू सॉल्व द क्वेश्चन। तो जो क्वेश्चन नंबर 10 से लेके 20 तक है ट्यूट शीट में, वो सारे के सारे रूल्स ऑफ इन्फ्रेंस से होंगे। सो टुमारोज क्लास में हम डिस्कस करेंगे रूल्स ऑफ इन्फ्रेंस। ओके, सो मैं नोट्स आपके अपलोड कर देती हूँ, बाकी जो भी कोई डाउट है तो आप पूछ सकते हो। Is it possible to rename your system devices with the roll number so that I can take attendance? Okay, class notes are posted on Google Classroom, so please have a look on this. Okay, today I will have to take the attendance verbally only. Just a minute. Roll number 1, 2, 3.
Present, ma'am.
Roll
3.
number 3. Okay. 4. जिनकी
Present, ma'am.
अटेंडेंस हो रही है वो लीव कर सकते हैं ना। रोल नंबर 3 यू कैन लीव। रोल नंबर 4,
Present, ma'am.
5,
Present, ma'am.
6, 7,
Present.
8,
Present, ma'am.
9, 10,